In the present video, we will discuss the EOQ model with gradual supply and shortage is allowed. This model is used when items are produced gradually, which means items are not received all at once. And this model also used when shortages are allowed, so which means customers may wait for the product. In the normal EOQ model, inventory arrives instantly and shortages are not allowed. In this model, so let's observe the figure. So here inventory Q1 is arrived not instantly and it arrives gradually at the rate of P minus 3 at the time of T1. So in this model, production occurs at a rate P units per year, demand at rate D units per year. Since production and demand happens together, so inventory increases at the rate of P minus D, where P equal to the production rate, D equal to the demand rate, and moreover, production rate is greater than the demand rate. So P is greater than the D. So this is the schematic representation of the EOQ model with gradual supply and shortage is allowed. So let's consider production cycle time. So total production cycle time is the small t, which is the summation of T1, T2, T3 and T4. So in the time period of the T1 production, it will be starts. So in the T1 time period, production begins and inventory is built up because production is faster than the demand and inventory is increases at the rate of the P minus D. And in this time period, T1 time period, maximum inventory is reached Q1 and Q1 equal to the P minus D into T1. And let's see the second time period, that is the consumption period. So in this period, production stops and demand is continuous. So inventory level is decreases at the rate of the small d. So inventory is falls from the Q1 to the 0. So Q1 equal to the small d into the T2. So next to see the T3 time period, that is the shortage period. In this period, inventory becomes 0, but demand still continues. So in this regard, shortage is accumulated. So in the figure you have to see here. So inventory is becomes 0 and demand still continues. In this regard, shortage is continuously increases and it is the accumulated. And maximum shortage is Q2, which is equal to the D into T3. So during the time period T3, inventory is 0, but customer demand continues at a constant rate D. Therefore, shortage accumulates at the same rate as demand. So shortage equal to the demand rate into the time. So then maximum shortage Q2 equal to the D into T3. So next we have to look for the next time period T4. So where the production restarts. So in this time period, production starts again, but back orders are supplied the first. So in this regard, shortage is decreasing at the rate of the P minus D. And the shortage is decreasing up to inventory is becomes the 0. So which is equal to the Q2 equal to the P minus D into T4. Next to observe the schematic representation of this model, and from the graph interpretation, so graph has a triangular shape. So first I have to observe the triangular shape of the ABC. Next another triangular shape is the CEF. So here observe the positive inventory region, that is the from A to B. So here from A to B. So this triangle is represent the inventory increases, and the another triangle B to C has to be represent the inventory is decreases. So triangle ABC is the positive inventory region and maximum inventory is the Q1. And next to another triangle CEF. So here from C to E. So one triangle here. This is to observe. Here shortage is increases and E to F. Shortage is decreases and maximum shortage is the Q2. Next we determine the average inventory and amount of shortage during the production cycle time T. So first we have to calculate the area of the triangle. First we have to calculate the area of triangle for the ABC. So where the positive inventory is maintaining. So from here area which is equal to the half into base into height. So this is we can be write down. There are the two triangles. So one is the half into, so base is nothing but T1 and height is the Q1 plus another triangle also there, half into T2 into so Q1. So this equation we can be written as area equal to the half into T1 plus T2 into Q1. Then average inventory is the area of inventory triangle divided by the total cycle time. Then average inventory equal to the, so 1 by 2 into Q1 into T1 plus T2 divided by small t. Similarly, average shortage will become the, so 1 by 2 into Q2 into T3 plus T4 divided by small t. So we know the average inventory and the average shortage. And production cycle time we are considering the small t, which is equal to the T1 plus T2 plus T3 plus T4. So previously we determined the, so relationship between the Q1 and T1 and Q1 and T2, Q2 and T3 and Q2 and T4. So from this one we can be written as the production cycle time T equal to the T1, which is equal to the Q1 divided by P minus D. Similarly, T2 equal to the Q1 by D and T3 equal to the Q2 by D and T4 equal to the Q2 divided by P minus D. So this equation we can be written as, so small t production cycle time small t equal to the 1 by P minus D plus 1 by D into Q1 plus Q2. So we find the total production time. So small t equal to the 1 by P minus D plus 1 by T into Q1 plus Q2. So let's consider capital Q equal to the total production lot size. The total production quantity capital Q is used for the three purposes. One is the to build the maximum inventory Q1 and remove the shortage Q2, and moreover to satisfy the customer demand while the production is running T1 and T4. So for with respect to these three purposes we have to use the total production quantity capital Q. So capital Q equal to the Q1 maximum inventory plus Q2. So maximum shortage plus customer demand in the T1 as well as the T4 time period. So with respect to the Q equal to the Q1 plus Q2 plus D into T1 plus T4. So from this equation Q1 equal to the, that is the maximum inventory, Q1 equal to the Q minus Q2 minus DT1 minus DT4. So next we have to substitute the T1 values and T4 values. T1 equal to the Q1 divided by P minus D and T4 equal to the Q2 divided by P minus D. Then this maximum inventory equation will become the, so we will get Q1 equal to the Q minus Q2 minus D into Q1 divided by P minus D plus Q2 divided by P minus D. So this equation we can be written as Q1 equal to the Q minus Q2 minus of D divided by P minus D into Q1 plus Q2. So this equation once again we can be written as Q equal to the Q1 plus Q2 plus D divided by P minus D into Q1 plus Q2. So which is equal to the Q equal to the 1 plus D divided by P minus D into Q1 plus Q2, which is equal to the Q equal to the P divided by P minus D into Q1 plus Q2. So from this one we can be written as Q1 plus Q2 equal to the P minus D divided by P into Q. So we got the relation Q1 plus Q2 equal to the P minus D divided by P into Q. And previously already we calculated small t value which is equal to the 1 by P minus D plus 1 by D into Q1 plus Q2. Then, so have to substitute Q1 plus Q2 which is equal to the P minus D divided by P into Q. Then, so small t equal to the Q by D. So next we calculate the total variable cost which is equal to the ordering cost plus carrying cost plus shortage cost. Then total variable cost in the terms of the Q, Q1 and the Q2. So which is equal to the ordering cost C0 into D by Q plus carrying cost 1 by 2 into Q1 into T1 plus T2 divided by T into CH. Shortage cost 1 by 2 into Q2 into T3 plus T4 divided by T into CS. So then this equation we can be written as D by Q C0 plus 1 by 2Q into P divided by P minus D into Q1 square CH plus Q2 square CS. And we know the relation. So Q1 equal to the P minus D divided by Q minus Q2. Then substitute. We will get the total variable cost in the terms of the Q and Q2. Then total variable cost which is equal to the D by Q C0 plus 1 by 2Q into P by P minus D into CH into P minus D by P into Q minus Q2 whole square plus Q2 square CS. The minimum value of total variable cost is obtained by differentiating the total variable cost partially with respect to Q and Q2, then equating them into the zero. Then we will get the optimal cost EOQ. So Q star, generally we represent EOQ equal to the Q star. Q star equal to the root of 2 C naught CH plus CS divided by CH into CS into PD divided by P minus D. So since the second order partial derivatives of total variable cost with respect to Q and Q2 are both positive, the values of Q and Q2 obtained from the optimum values, therefore Q star equal to the root of 2D C0 by CH into P divided by P minus D into CH plus CS divided by CS. So remember this equation. And moreover, this is for the optimal production lot size, Q star value. Similarly, you have to remember another equation, Q2 star, which is for the optimum level of shortage. Q2 star equal to the Q star into 1 minus D by P into CH divided by CH plus CS. These two equations I have to remember. So have to remember the another important formulas. First one is the optimum production cycle time T star, which is equal to the Q star divided by D. So which is equal to the root of 2C0 divided by D into CH into P divided by P minus D into CH plus CS divided by CS. And one more equation, optimum inventory level Q1 star, which is equal to the root of 2D C0 by CH into 1 minus D by P into CS divided by CH plus CS. And one more equation, total minimum variable inventory cost TVC star, which is equal to the root of 2D C0 CH into 1 minus D by P into CS divided by CH plus CS. So this is the EOQ model with gradual supply and shortage is allowed, and thank you.